So today we talk about React State Part 2, and this time it's all about this thing called immutability and update patterns in React. We'll do another review, talk about render again. You can't have any discussion until you talk about render, of course. It really permeates everything. And state. State, as we know, is just the heart of React. You can't talk about React without talking about state. And we'll talk about how does React compare state? And this term reference equality optimization, which sounds kind of intimidating, but it's actually something you know already. And we'll talk about the problem with mutating state, because that is a problem. And we'll explain why. And we'll look at ways to get around that. Talk about immutable update patterns. In other words, changing things without changing them. Well, how does that make any sense? Isn't that an oxymoron? Immutable update? Doesn't make any sense. We'll take a quick look at JavaScript variables again. We'll talk about this concept of values versus references and some of the pure array functions that are out there. You've used quite a few of them. And we'll talk about the spread operator. We make extensive use of spread in React, a lot. And well, there's some complex states, some examples of that, and then just more examples of immutable updates just for the whole rest of our time. So this is all about how we change state, or how we tell React to change state, and how to do it properly without breaking things. We have to consider some of the things that React does, or understanding what React does in order to play with React properly. Otherwise, weird stuff just happens. All right. So I've got my app.js. It's the same one. I don't change it. And we're going to pick up from yesterday. So let's go ahead and make ourselves our component for our counter. Got to have a counter, right? And we'll call this counter.js. Make it a separate file this time. Now, if anyone's played around with these suggestions from VS Code, there's a bunch of them. If you type R, you get a bunch of suggestions, right? We'll type in R, take a look, C, oh, a React class component, or RSF, a React stateless function. What the heck is that? Hit enter. Oh, you get a function. Now, it's funny that it's called React stateless function. But this is just a component, right? This is a component, although it's got the don't like that. But apart from that, this is just a regular React functional component. But it seems that VS Code hasn't quite clued into the fact yet that 2019 has come and gone, and they still call this a stateless function, because back in the day, we couldn't put state in functional components. So it's a function. It's a functional component. So we called these the stateless components. Come on, Microsoft, wake up. It's 4 years ago. Come on. We can put state inside these. So I'll leave it like this. I'm not a big fan of this, but they seem to like it. So I'm going to leave it there for now. It doesn't really matter. Okay. Let's go ahead and add our state. I added a snippet, a VS Code snippet. Anyone use snippets? We talked about that yesterday. I've got one for use state. I just type in use, and it'll give me a use state, and I can go counter, tab, it'll auto-complete that, and look at that. It doesn't, unfortunately, import my use state, which I'm not happy about. I have to go control space there at the end of use state, hit enter, and it will import. I'm just so lazy, really. I always like think and have it type for me. If I think I've lost all my fingers, except two, I could still probably program with all the shortcuts I've learned. We're lazy people. Developers, even though, yes, we stay up till 5 in the morning, we will take any shortcut to make things faster for ourselves, which is great quality to have as a developer. You want things to be fast and efficient. If we liked work, we'd have real jobs, right? So we want to be able to make things as easy as possible. There's my counter, and I'm going to go ahead and put my counter here. There, along with my usual button, and I'm going to have an on click equals, and I'll make some functions for this. I'll make an increment function. So let's go ahead and let's make our our usual cast of suspects. So make a function. I'll call it increment. There. And of course, this is going to be my set counter to my counter plus 1. And we know this because we're using state, and state lets us do what? It lets or allows things to survive a render. Quick pop quiz. So who can tell me what the definition of a React component is? What is a React component?
It's just a function.
Who can spell React component? Because apparently I can't. Component. There we go. Okay. It is a function. Any function? It's a function that does what? You're right. It's a function, and you're right. It is just a function. It has one special quality.
It returns JSX?
Correct. Returns JSX. Any JSX will do, including a fragment if you want. Exactly. So knowing that a component is a function, what is a render of that component? Well, since it's just a function, what's the only thing we could do with a function?
Is that calling the function?
Yeah, exactly. That it couldn't be anything else, could it? It could not be anything else but call the function. We're talking functional components, of course, because it is, post 2019. Okay, that's a render. Call the function, because it couldn't be anything else because a component is a function. Okay, so yeah, those two things. And lastly, what causes a render? What causes a render? What causes React to render something?
An update of the state.
Correct.
State.
Yes, that's right. A change of state. Since state is the core of React, React reacts to changes of state. That's what it does. So good thing to remember, React reacts to state changes. That's all it does. Nothing happens unless some state changes. Good to keep that in mind as you're coding. You go like, why is nothing changed in my app from doing all this stuff? Well, you have to change some state for something to happen. Very important. Let's put an asterisk beside that. Okay. So let's keep these 4 things in mind as we go ahead. Okay, so we know we have to do this. We have to do a set counter. This is a state change, right? So we know that this should trigger a render. So there's my increment. I'm going to add my other ones because they're just so much fun to write. So decrement, and they're also kind of easy. And clear. Set counter to 0. So we'll go ahead and assemble our little counter. Shouldn't be hard now. And we'll call this our plus. We'll put our clear in the middle. I like it, makes more sense. There. 0 and minus. Now, here's an interesting point. I'm using named callbacks, named functions as my on clicks. We can do this. We can also, if we want, use inline callbacks. You will see both being done. And for instance, we could do this. Instead of calling the increment function, we could have done this. Arrow set count to, or counter rather, to counter plus 1. There. And I'm sure I messed something up, but yeah, there we go. Unbalanced parenthesis, probably. There it is. Okay. Yeah. This also works. And my view is, if it's a simple one-liner, this is totally fine. Unless you have a reason for these being outside, which sometimes you do. Okay. So, but I tend to like this only because it's just easier and my mind doesn't hold too many things. So this just looks easier, right? But these are equivalent. So the question is, well, when do you decide? Because I've seen it done both ways. Like, does it really matter? And the answer is, yeah, it does. There are some situations where you have to do it this way. You haven't got any choice. And we'll actually come across one of those today where we can't make a named function, which you say, why? Can't you always make a named function? Well, not always. Sometimes you have to do this. What this means is call the onClick function, which is called by the DOM. You click on a button, the DOM, your browser, calls the onClick. And that onClick is in response to an event. Remember jQuery? We had event handlers like dollar, on click, blah, blah, blah. And you get an event as the parameter to your onClick. Exactly the same thing with React. This is actually a DOM. This is browser. And every event handler gets an event. They all do. So there we go. Remember we covered, I think on Monday, we talked about inputs, managed inputs, event.target.value. Sound familiar? Yeah. So they all get an event. Now with an onClick, we don't use it. It's just not used. So we don't usually put a parameter here for an onClick handler, but it's there. We can console log it. In fact, let's do that. I'm curious. Let's take a look at the event. Increment. I'm going to go ahead and in a second, we'll console log to see, do we in fact get an event? Right. So there it is. So I'm going to make these named. It's just easier than inline. And we'll do an example later on where we have to do it the other way. Okay. So there's my counter. Looks pretty good. Let's go ahead and put a counter in here someplace. We'll say hello immutable, which I will also spell wrong. Oh, I think it's even close. Okay. It's going to change. Make sure. Oh, I think oh, it did. It just took a bit of time. Okay. Sometimes the first time I start a React app, it does kind of take a second to kickstart loose. All right, so this is my counter. Should find it. It did. There's my counter with my auto import. And I'm lucky I should get a counter in there. That works first time. Wow, that never happens. Look at that. Woohoo. Okay. Thank you. Thank you. Okay. So let's take a look. By the way, we're going to go ahead and just take a look what we got back from that event handler, because this really is a DOM event handler. It is the browser calling increment. And this is going to be kind of important next week. Let's take a look at console log event. What the heck? Let's just console log that. And what did I get for an event? Just for fun. Well, an object. Yeah, so it's lots of stuff, right? Lots of stuff. Oh, XY on the screen. Kind of cool. Oh, it was a click. I know that. Okay. The window. Okay. It has a window view. So lots of cool stuff. None of which I care about in a click, honestly. But I might be interested. Okay. So this is useful for games, knowing where the person clicked. So we definitely use this for a game. Where did they click on the screen? But for most of our React stuff, we just ignore the event. It's not usually used. So we're going to got to get rid of those for now. The only place we use it is in inputs. And that is the only thing I know about events is event.target.value. All the rest I have to look up. Okay. So there's our button and our counter works great. Okay. So we did talk about change of state. Let's go ahead and add our console log here. There, we'll go console log rendering counter. Man, 9 years in engineering school, I still can't spell anything. Papers. There we go. Okay. Rendering counter. So I should get rendering counter 0. Makes sense. I plus rendering counter 1. So it renders every time. We know that. Interesting point about the render is we know now it runs the entire function from top to bottom, including reconstructing all of these functions and anything else it needs to do. And you might think to yourself, well, that's kind of inefficient. What if this is a huge function or a helper function, same thing? Would it have to reconstruct the whole thing? The answer is yes, it would have to build all these functions over again, but they never change. Like, why? That's kind of inefficient. And you'd be completely correct in thinking that. That is one of the apparent downsides of functional components. In the class component, they get built once, never again. Functional components, since the whole thing has to run again, it has to reconstruct these functions again from scratch. Now, it's very fast. It's very, very fast. Compared to the speed that the DOM updates, it's lightning fast. It takes, to update one eye on the screen, you can process 50,000 objects in the virtual DOM. So it's not a huge problem. But there is some inefficiency introduced. There are ways around that in React. There are other hooks in React that help us with these problems. We won't talk about these today, but there are ways to increase efficiencies, just so you know. Okay, but really a render still is run the whole function. So far, so good. It is rendering, happily rendering away. Render, render, render. Okay, awesome. Now, I know we left you with a cliffhanger yesterday where we did something strange. We instead made our set counter to counter or set counter to 0, right? This is a set counter to counter. There. Go ahead and we'll clear that. Okay. I click the plus button and it rendered once, but now it's not rendering again. Let's again. Nothing. It's just not rendering. It's staying at 2. Nothing is happening. It's clear, to be sure. Clear. It is not rendering. But I'm clearly, as we know from yesterday, I'm calling set counter. I am definitely calling set counter. Nothing changes. Nothing's changing. So this is a very, very important thing to understand about React. Remember we talked about what causes a render? A change of state. A change of state. Not just setting state, but a change of state. So React is smart enough to know that just give it the same counter. It's the same counter. I'm not rendering just for that. You didn't change anything in your state. There is no reason for me to update. Okay. In fact, let's take a look and do an example of what React actually does in detecting if state has changed. Let's make ourselves a little file here. I'll call it, what should I call it here? Trying to think what to do here. Make a little file, not inside source. I'll call this set state.js. I'm going to make up or pretend that I'm React. Okay. So I'll make a function and I'm going to call it set state. Set some random state that takes a value there. And I'm going to pretend I'm React. I've got this state variable just sitting out there where I'm going to save my state, kind of protected from renders, right? So this runs a couple times. It doesn't matter. This will always survive as long as the function is, the whole thing is running. There's my state out in React land. And here's my set state function. Okay. So you give it a value. Of course, what React does, it checks if the value is equal to state. Well, we're going to console log here. No change. There. Okay. No change. And we'll even put a little, we'll say state is and value. I'm kind of printed everything there. So there is the state you've got, and there's your current value. Okay, there. So if I run this set state, and I give it 1 and 1, I should get this. Okay. Now, otherwise, I'll return 2. It's done. Okay. Otherwise, they must be different. So I'm going to console log the state's change. I'm making a little function to kind of pretend I'm React. There. State has changed. There. exclamation mark. Look at that. And I'll say state equals value. It saves that. And then trigger render, which we're not going to do because don't know how. Render. There. So I'm pretending I am the function that React uses to determine if state is changed. And then I save it. Equals value. Okay. Pretty simple function. We're going to call our set state with 1 and 1. Okay, let's go to my thing here. Where am I here? Oops, CD React. And I've got all this. Got too much stuff in here. There we go. Okay. So I'm going to call node set state. Oh, set stat. Better change my spelling here. Although stat it works, I probably should do it right. Is that closer? Okay. State is changed. It went from undefined to 1. So definitely worked. Let's call it again. 1 and 1. What are we going to get? No change. Makes sense, right? And we can call it as many times. Actually, sorry, just 1. My mistake. As 1 parameter. I've got 2. There we go. I can call this as many times as I want. It's changed the first time, and it simply ignored those subsequent changes. So I could call set count with the same counter. It doesn't matter. This is not going to trigger a change of state, is it? React says, no, there's no change. I'm not doing anything. Okay, so this is how React checks state. It checks, are you giving it something new? Okay. And I am here, and let's just be fun. Let's do one here. There. We should get a change of state happening here sometime. Let's take a look. And there, something interesting happened. It noticed state change. So this is our imaginary React state change and state setting function. Okay. So now we know that state will only change if you give it a different thing, something different, something interesting. Otherwise, React will simply ignore what you've done or ignore your set counter. Okay. Let's go ahead and fix this one. Let's do something else interesting. Okay. Let's go to our app, and we're going to add ourselves a little input. Okay. Or maybe I'm trying to think what I should add here. Yeah, I'll do an input. I like inputs. I haven't done one of those in a while. So we'll do an input. I'll put it here. Okay, so I'm going to put an input because I like inputs. They're fascinating the way they work. Input, type equals text. That's kind of default anyway, so I'm okay with that. Okay, and I'm going to, as we know, since this has to be a managed component, I'm going to save my text in some state, because without that, I just get an input that just works on its own. And a React has no idea what's going on in this input. If this was jQuery, that's fine. I'd go and get that value. If I had a button, I'd click on the button, and the button handler would go and grab the value of that input and do something. But that's not how React works, is it? React is all about state. We don't go and grab things from the DOM. So React needs to know what's going on with that input all the time. So we make ourselves some state. So you use state again there, and I'll call this my, what should I call it? Text. Why not? Text, and I'll start with an empty string. Okay. And now we know we have to give our input 2 things, don't we? What are those 2 things? Anybody remember? What are the 2 things we need to give our input? One of them is value, right? Value equals.
Value and on change.
Right, value equals text. Exactly, value equals text. We'll try that. So now it's value equals text. So now, and use state. Oh, man, import use state. There we go. Okay. It got confused. Okay. So now, no matter what I type, it's always empty string, right? So you have to have both. Otherwise, you type something, it says type equal value equals that always. The value is always text, and text, of course, is empty string. So it has to be on change equals, and I can give it a function to save the text, or I can put it in line. This is kind of common. It depends. Make a function for now, because I'm still not confident typing these end lines. So I'm going to make a function called, I don't know, text changed. It really doesn't matter what I call it. So make a function, call it text change, that takes an event handler like this, right, where it takes an event there. And we do our set text to event dot target dot value, the only one I know. There. Okay, so now when I type, it shows up. And let's look at my state as I type, which is kind of cool. Let's watch my state. Let's go to here, components, look at my app, make it a little bigger. Oh, that's pretty big. There. As I type stuff in, my state changes along with me typing. Very cool. And interesting to know, if I put my console log here and I say rendering app, we know that as I type, it renders app. Every time I type, it renders app. Every single character, it re-renders the whole thing, which is kind of fun to think about, because what that means is every time I type one character, it's rebuilding the entire DOM every single time. It is. Well, of course it is, because what's a render? Run the whole thing, and it returns the entire DOM every character. Every time I hit a period, I just rebuilt the whole thing. Seems kind of inefficient, doesn't it? Like, what's with that? Are you kidding me? But of course, it's in the virtual DOM. It's all happening as React virtual DOM objects, which we'll actually take a look at, I think, next week. Let's check the schedule. So they're in memory. The browser never sees that. The browser just sees the deltas or the changes. React, as we know, I think we talked about this on Monday, React, when it does its change of state, it then compares the virtual DOM with its copy of the browser's DOM. If it sees any differences, it just sends those differences to the browser. So if I type a dot, it's just going to send that dot to the browser. It's not going to send the whole thing. So it's actually pretty fast. It just seems inefficient, but there's much more inefficiencies in the DOM here. This is orders of magnitude slower than the virtual DOM. So there's not much cost for rebuilding everything. This sounds kind of cool that every time you type, the whole thing's getting built. I love that concept. Inputs are fascinating in React. Okay, so this is working. So now my state is changing. So now I'm going to go ahead and I want to have a little list here. I'm going to make a list of stuff. So when I add things like maybe friends, you know, Bob, there, easy name. I make a button. I'm going to add a friend to my list. Let's go ahead and do a couple things. I'm going to make a list. So I want to have a list here, make a use state for myself. I'm going to make a list and set list and empty array. I'm going to build myself a little list, just of anything. Okay. And I'm going to render that list. So I will need to convert that list of things to a list of HTML stuff, like maybe an LI. So what array function is the React developer's best friend? What's the one we always used? Yes, map. We use map. So we go const, I'll call it, what should I call this thing? Maybe my item list. Item list equals my data list. I could have called it data, but data is such a generic name. try to avoid calling things data unless they truly are data. It just, the temptation is to put the word data and you find yourself getting burned later on because what's this data thing? Oh, crap. So call it maybe list data or initial data or friend data or something. I just call it list, which I guess is generic also. But anyway, dot map. Yes. Okay, we're going to convert this list to a list of LIs. That's not a bad thing. So I'm going to map it to a bunch of LIs. So I'm going to take for every item or I'll say item. Okay. There. I'm going to return an LI. I'm doing it longhand right now. This could be done, of course, without the curly braces, but I'll do it the longhand for now. So it'll be an LI. There we go. And it'll just contain the item. There. Okay. Wow. Has it crashed? Let's take a look. No errors. Wow. That's a big surprise. Look at that. Huh. Okay. I must be doing something wrong. It'll crash in a second, I'm sure. And we're going to go ahead and render that list. Let's go ahead and put it right here underneath our list. We'll just render a UL, and we'll stick that item list inside there. Item. This is something we do all the time. Doing maps and lists is just one of those things we just do constantly as React developers. The cool thing about JSX, it auto expands arrays. Isn't that cool? I love that feature too. It just, you give it an array, it just expands it, just automatically. Unlike Tweeter, you had to go for tweet of tweets, create tweet element, append tweet. No, we just give it an array and it just expands that array. It's a really cool feature of JSX. I love that one. Okay, so it'll expand my array of LIs and just put it there as a bunch of LIs as a expanded text. Okay. And there it is. And of course, I have nothing in my list. Let's go ahead and give it something. Let's give it a couple of interesting things. We'll say item 1 and item 2. Wow. Not bad. I should probably put my curly braces around my item there. And I'm going to get, look at that. Magic. A nice auto expanded array. Okay, so what I want to do now is I want to type stuff in. I'm going to make a button and it's going to add something to that list. Okay, so let's go ahead. We'll take out these for now. Just want to know that it worked. By the way, interesting note. What if we had done this and started off with just nothing in our initialized state? What are we going to get here? Let's take a look. Ugh. Yikes. It crashed. The list is undefined. And it says, wow. Can you tell me where? Let's go to the console log. There. Okay. Okay. App. Immutable. Should tell me where it's undefined. Yeah, it's really hard to find. Here. Immutable. It's getting there. It's hard to find. These are nasty errors, okay? App.js line 6. That wasn't very useful, was it? Okay. So what happened was, and this is a common problem with state in React, you have to survive or you have to be able to render it the first time. It has to be able to handle the very first render, right? I'm going list.map the first time and list is undefined. So you have to give it something in there. Even if we're loading it maybe in a data fetch as part of this, it'll be asynchronous, we always have to give it something. So you may see this quite often. If you forget to initialize your array, it won't survive the first map. It's one of those common things. All right. No, it works. Okay. So this is why we almost always give it initial values unless you truly want undefined as your initial value. And there are cases where I actually want undefined, but not that often. always empty string here, because you get other nasty errors with the React if you don't do that. And for arrays, always give them something in there. So you can handle your very first pass through your render. Okay. Let's go ahead and add myself a button. I'm going to put it right here, I guess. Yeah. We're almost there. This is about as much JSX as we're going to do. Okay. And I'll just say add, button called add. There, add. So I type something, add. And I'm going to make a function. Okay, on click equals, and I'll make a function called add item. There. And I'll make my function called add item. Add item is a click handler, no event needed. Okay, how we doing here? Oh, no crash yet. That's amazing. Okay, very good. By the way, let's talk quickly about the anatomy of a component. I've got things in a certain order here. There's my component function starts. I've got my hooks, my state. Almost always your state comes first. Sometimes not, but almost always state comes first, followed by other hooks. Then function declarations, internal functions, closures, as we know now. Then do stuff, and then your return. These are, so hook, 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 function, function, actually do some stuff, build my list, and then my return, which is my actual results of my render. Okay. Try to keep that order. And usually I put the star of the show at the bottom. Right before the return, I put the star of the show. It's my list. This is what this app's all about, or this component. It's all about this list. That really is the last thing I do before my return. It makes it easy to come back to for somebody else. See, what's this component doing? So look above the return. Who's the star of the show? That's the star, the list, or the item list in this case. All right. So now I just need to write a function that is going to add my item. Okay, well, this is easy. I've got an array and I've got some text. Easy. How do we add something to an array? It's easy. This is week 1, right? Well, I've got my list. And what function do we use to add something to an array?
Push.
Yeah, not a trick question. Exactly. It's push. Exactly. It's push. Exactly. Arrest dot push my text. Great. Okay. And I probably should set my list, set list. There. Better save it again, right? So now I've got different elements in my list. I'm going to set list, so make sure that I can save my new list. So list.push and save that. Okay. Let's go ahead. I'm going to just be sure, refresh everything. There's my initial renders, rendering counter, all looking good. Okay. Let's go ahead and make it a little taller. Okay. Let's add something to my list. Let's add a friend. Who's a good imaginary friend? Ah, Nathan Brown. Any upload fans in the crowd? Really? Ah, awesome show. It was a cool show. Yeah. Okay. Add. Oh, let's take a look. I got any errors today. I got. Oh, that's not an error really. I'm getting this child unique key thing. We'll fix that really quickly. It's not really an error. It's more of a warning, but it doesn't like it. So I'm gonna do it really the really bad way. I'm putting an I in there. Okay. This is the awful way to do it. And I'm gonna say key equals I. It's kind of the worst way, but it's all I got. I haven't got anything else. I mean, I could make the key the item, but I might have a duplicate, so I wouldn't like that either, right? So, okay, let's go ahead and do that. Refresh our app again. Okay, so try somebody else. How about James Holden? Okay. Any Expanse fans in the crowd? Come on. What? Oh, man. Oh, jeez. Okay. Okay. How about Roy Bennerman? Any IT crowd fans in the crowd? Ah, okay, that's a required show. I think in many companies it is required that you watch the IT crowd. It's an old British sitcom based on IT. It's really funny, actually. Um, great jokes. Okay, anyway, doesn't matter. We'll add Roy. Can't believe no one's an IT crowd fan. That's like an interview question, right? That's an interview question. Ah, okay. During the break, I want you guys to Google what does IT stand for in the IT crowd. Okay, all right. Add. Where the heck's where'd it go? Huh. Add. Okay, hold on. I'm going to go ahead and console log my list. Just make sure it's there. So we're going to go ahead and console log our list. What's
It's
going
because
on
you're
with my
not
list?
accepting a prop into the add item or
Take a look. Well, don't have to, right? Because it's an on-click handler.
oh, right. Okay, sorry.
Does we could put the event there, but it's not really needed for on-clicks. But we know that this text is there because as I type, text is being updated. And I know my list is there, so I'm simply pushing the text into my list, which should be there. Okay, let's take a look. So now I'll type again. Okay. Tom Cruise. He's like a B-lister, isn't he? I always slam Tom Cruise. Fun fact, I had a buddy who worked on some of the MI movies, and he had a word of advice is, Gary, one thing you should never do, never give Tom Cruise your phone number. He didn't elaborate. So anyway, all right, let's go ahead and add Tom. Well, he's in the array. There we go. But where is he? Come on, Tom. Come on, step into the danger zone. Ah, I've got 3 Toms, which is 3 too many, but nothing on my screen. So what's going on? Clearly something's going on, right? I have a problem here with my Toms and with my list. Nothing is happening. Huh. Let's try something else. Back. Whoa, my Toms showed up. When I 4 of them. Where they go? What's going on? So clearly I have some unexpected and unpredictable behavior of my app, don't I? This is not functional. Something bizarre is going on in my app. So what have I done wrong? Well, let's go ahead and take a look at this. All right. Let's talk about how React compares state and reference equality optimization. Let's go back to our set state. Well, still not wrong, isn't it? Okay. Let's go in here. Let's talk about variables, by the way. So JavaScript has variables or values. For example, we have some basic values or simple values, right? Such as number, right? 4. There. That's a simple value. Or a Boolean, like true. So these are really simple values. JavaScript also has complex values, things like arrays, 2, 3, and objects, which I'm still easy to type one in. Okay, there. So these are complex values or complex items in JavaScript. So we know that in week 1, we wrote ourselves a function called EQ arrays, didn't we? EQ arrays, I think it was called. There. That took 2 parameters, AR1 and ARR2. There. And we might have tried this return, or if AR1 is equal to ARR2, then we would return true. There. Might have tried that in week 1. I might have. Did it work? No, of course not. This doesn't work. But why? Why didn't that work? They're clearly different. If I give it 2 arrays, they should be not equal. Okay. But what's happening is I'm always getting not equal. Even with 2 equal arrays, it still gives me not equal. So what's going on? Let's take a look at why that happens. And of course, we may already know this. It's kind of computer theory. So we're going to do a little bit of real deep computer theory. It's not too bad, but a little bit. So let's look at the memory of a computer. Bunch of zeros. There. Looks like the matrix. All these zeros and ones. Okay. So if I make a variable const x equals 4, there. What does my JavaScript actually do? Or my computer actually do? Okay, because all computers work the same. They're all just a bunch of zeros and ones. But we'll make them numbers for now. Just a bunch of numbers in memory. That's all there is. So if I say x equals 4, well, what JavaScript does, it puts a 4 right there. And that becomes my x. It assigns that to x. It puts in this value x4, okay? But if I give it a complex object, such as if I say const a equals 1, 2, 3, okay, it doesn't actually put 1, 2, 3 inside the variable a, because it can't, because variables can only hold one thing. In every computer language out there, a variable can actually only hold one thing, and that is a number. That's it. A variable can, in other words, like technically zeros and ones, but it's a number. So every variable, so if I go const x equals 4 or 5, I'm putting 5 in x directly, and this works. But if I say const a equals an array, it doesn't put the array inside a. What does it put? If it doesn't put that, what does it put? What JavaScript does, it finds a place in memory and it puts your 1, 2, and 3 in it right there. There. And what you get is the address. What is that? How is this? Is like 28, 29. I'm going to say that's like position 56. So what you end up getting is actually 56 and array. So what JavaScript does, it saves this information in that variable. It says, hey, at location 50, well, whatever, 56, there's an array. That's what A is. The array is actually here. Okay, that's the array. Make another one, const B. Okay, if I make that also equal to 1, 2, 3, what happens there? Well, it finds another space. I don't know, down here someplace. 1, 2, 3. There. And it says, yeah, this one is now at position, I'm only guessing, 73. And it's also an array. There. That goes into B. So these are clearly different. 56 is not equal to 73, is it? They're different spaces or different places in memory, different references. It's called a reference, sometimes called a pointer in some languages, a pointer to a place in memory. Now, we see none of this in JavaScript, and it's actually not possible to see it. I've tried. JavaScript has no facility to inspect the contents or the references of an array. It just doesn't have that. But this is what's happening under the covers. So A is actually 56. There. And B is actually 73 or something. And of course, now it becomes clear why we can't compare A and B. Even though they both contain 1, 2, 3, they are totally different addresses or references. Okay. So we had to do it the hard way, didn't we? What do we have to do? We had to do a for, and then I equals 0. You know, I is less than AR 1 dot length. It was hard anyways. Painful just typing it. Okay. A lot of work. And if it was a nested array, we had to do even more work, right? Like do it again. Maybe it had an array of objects. Well, now we got to do objects. What are the object containing arrays? We do more. It gets pretty complex, right? It's a lot of heavy lifting, as you can imagine, to compare two potentially complex arrays that you don't even know what they have in them. You have to handle. Is it got an object? Does it have an array? Does that object have an array? And so on and so forth. So a lot of heavy lifting. Okay. Just to compare to arrays. So, well, let's talk about React. So React is all about doing things fast. So which way do you think React chose to compare to arrays? The heavy lifting way or the easy way out? The way we tried on week 1. Who wants to guess? They chose the easy way. Yeah. They chose this. So this also works for arrays. So here, if I go set state to an array, 1, 2, 3, there. If I do it again, well, actually let's put a value here. Let's go const array equals 1, 2, 3. This will work better this way. There, if I set state to array here, an array, what's going to happen? Let's take a look. No change. Doesn't make any sense, but there's no change. What if I do this? Dot push. Tom Cruise. There. Okay, let's take a look. No change. There we go. I've clearly changed the array, but React says, no, there's no change. Nothing's happened. I'm not doing anything. So it doesn't matter what I do. I can push away, do it again. Hate doing that, but do it again. I need new friends. Okay. Yeah. No change, even though clearly this thing's growing. React did not detect that I'd added yet another Tom. Okay. And this is a problem. And you may also notice, wait a second, I also modified the one in memory. It's my state here. I'm console logging my original state. I've also modified that. I probably should have done that. So I'm actually modifying my React state without telling React about it. This push actually modified that state, which is also kind of scary, which is one of the reasons for my weird effect. So the problem is React doesn't do a brute force analysis or a brute force comparison of an array or an object. It just does this. That's it. It assumes that if the references are the same, it must be unchanged. If the references are different, it must have changed. And they call that thing reference equality optimization. In other words, if the references are equal, there's no change. This just means fast or lazy. So compare references because we're lazy. There. Or because we like to be fast. That is how React compares state. Very important to understand that and be aware of this as we do state updates in React. Okay, so we'll go ahead and play with this. Let's take a quick break. And when we come back, we're going to start talking about how we deal with this as React developers. Okay, so see everyone in 10 again. All right. See you all soon.
I think you're still muted, Gary.
Okay, here we go. Let's carry on with our talk on immutable update and state. So now we know that React, when it compares state, it does it the easy way, called reference equality optimization, which just means this: compare the references, which kind of explains now why React is refusing to render anything when I add my friend or my item to my list. No matter what I do, I can add Moss, another fun character. Nothing happens. Okay, but if I have a change of state here, okay, or type something in here, now it renders. Because not only is React refusing to update or render because it doesn't know what this, what I'm actually modifying the original version. Remember, when I call use state, what React does, it sets aside a piece of memory in React to save my state, and it gives me back that value. So when I said use state with empty array, React set aside a piece of memory for me to save the array, and it gave me back the reference to that array. But when I do a list.push, I'm actually changing directly React's memory rather than doing it through a set list function. Just by doing this, I'm actually changing memory. In fact, let's take out that set list and watch what happens. Now I'm not doing anything. If I add, let's pick another friend. Freddie Mercury. There's a cool friend. Nothing's happening. But if I type again, it adds. So I'm actually modifying, you could say, React's internal copy of list directly. Bad thing, okay, because nasty things can happen. We only want to use these setters or these set state functions to modify state. If we do it this way, list.push, and modify it ourselves, we can cause all kinds of nasty things to happen. And this is the least of which could possibly happen, which we don't want. All right, so knowing that, then how do we do it the correct way to keep React happy? And there's a number of ways we can do that. And this is called setting state or updating state without modifying or mutating the original. That's why it's called immutable. We cannot change the original one here. Now, for values, it's easy. For a counter, who cares? It's just a counter. Making count equals 5 or 6, it doesn't matter. It's our local copy. We're not changing anything. But for complex items such as arrays and objects, it does become a problem because we can do things like push or any other modifying, or sort, for instance, which would modify the original. So we have to use functions or methods that do not modify the original, right? Or alternatively, we make a copy of the original and then modify that. That passes. So for instance, if I did, instead of push here, what if I made a copy? Const new list equals. And there's a number of ways we can make a copy of an array. One of the oldest ways is simply go to list dot slice. List dot slice with no parameters makes a copy. This is actually the way we used to do it all the time. List dot slice makes a really fast copy, and then I simply push my new list and then set my list to my new list. And this way, I'm not modifying the original, and I'm now giving a new array to my set state function, which React goes, hey, that's different. I can work with that, and it should render. Let's take a look and see if this gives me a change in my behavior. Okay. So let's go Bob. There. Oh, that's much better behavior now. I'm getting exactly what I expected. Okay, and Freddie. Hey, very cool. Tom. So now I'm getting exactly what I expected. I'm getting immutable updates to my list, but I'm not modifying the original, which is making Rack much happier. And now it's rendering every time I click add because I'm giving it a new list. And this is perfectly acceptable. It's more of a longhand way to do it, but there's nothing wrong with this code. It's a little long. Okay, so this is it. The pattern, we make a copy, modify the copy, and then save the copy. That's permeates all of React. That is the way it's always done. Make a copy, modify the copy, save the copy. Don't touch the original. No mutating, no mutants. That Senator Kelly? No mutants. Get those mutants. Yes, we don't want any mutants in React. We are mutant free. Okay, do not mutate your state. And that's almost all the time you'll hear your bug is because you mutated state, and they are nasty ones to find. Nasty bugs can happen. And it becomes quite an issue sometimes. If it's a fairly complex state object, as you can imagine, it becomes a real problem not mutating state. We'll do an example of that in a little while, which is why we try to keep our state as flat as possible and not have this problem mutating state. Even having one list gave us problems. What if we had an array of lists or a list of objects? That has more potential for mutating state. So now we can use slice, but there's a better way, isn't there? What's a better way now in ES6 to copy or make a copy of an array? What's an easier way?
Using a spread operator.
Exactly right. Using the spread operator. And that would be something like this. Dot, dot, dot. List. Oh, not app.list. List. There. Take a look. What happens with that? Does that work? It does. Same thing. Let's double check to be sure. Say, Betty. Freddie. There. And Tom. Okay, there we go. All right. Okay, works great. So the spread operator does in fact work. It is an easy way to make a copy of an array or of an object, by the way. All right, so now let's take some time and talk about the spread operator. So let's make a new file here. We'll call it, put outside of source again. We'll call it, can I spell this one correctly? Spread, I think I have this time. Okay, so let's say you're in an interview and the interviewer asks you, I've always wondered, what does a spread operator do? I hear this term all the time. What does it do? You're a developer. Can you explain it to me? What does a spread operator do? So the question is, what does the spread operator do? And I ask this question all the time in interviews. And depending on who I'm interviewing, I'll accept different answers. Okay. So who can tell me? What does the spread operator do? There are no wrong answers. That's always a trap, isn't it, when they say that? Go
It
to these
just
seminars.
expands the content of either the array or the object into its component parts. So each property or each array item kind of thing.
Yeah, that's true, right? Well, what's an easy way of saying that? What would we commonly say if someone asked us? We'd probably say makes a copy, right, of array or object. That's the usual answer I get in interviews. And there's nothing wrong with that answer, really, if it comes from a fairly junior developer. Nothing wrong with that. That's a true statement. This is true. That is a true statement. it does make a copy of object array, or kind of true. We can use to make a copy. There, that's more a true statement. We can use it for that. But if I'm interviewing an intermediate or a senior developer, and they give me that answer, which they invariably do, I do say, well, yes, that can be used for that, but that's not what it does. We all know that. We know that the spread operator doesn't do that. What does it do instead? So what does it actually do? We can use it for lots of things, such as making copy and other stuff. But what does it actually do? It is an operator. Operator. Okay. What is an operator? We use these terms all the time, but what do they mean? Operator, spread operator. What's an operator? Well, operators are things that operate on values. What's the very first operator we learned? Probably age 3, 2, 3, 4. In my case, it was like 8. Okay. What's the first one we learned?
Addition, maybe?
Plus, exactly.
Plus.
Plus 1 plus 1. Yeah. Although I think some people, some kids probably learn modulus first. The Mensa kids, or the Montessori kids. That's right. The Montessori kids, they probably make them learn the modulus first, and then they say, well, we'll learn the low class gauche plus and minus later. But no. So anyway, okay. Yes, we learn the plus operator, and there's plus, there's minus, there's some other ones that I can't remember. I think there's multiplication there somewhere. I think there's a divide. There are 2 minuses there. Okay, so these are some classic operators that we all are familiar with. Okay, they are operators. They operate on operands. Operands, there we go, operands. That's just the stuff they operate on. For example, 1 plus 1. There. 2 operands, 1 operator. Okay. So one can say that operators are the verbs of the programming language. They act on nouns, which are the values, or a variable. So const A equals 2 and const B equals 4. Well, now we have, of course, const X equals A plus B. Super simple stuff, of course, right? Here's my operands, and there's my operator. So these, we can call them binary operators. They operate on 2 operands. We have another class of operands, don't we? That can work on a single operand. So let C equals, I'll go with 5 this time. I can go C++, can't I? Ooh, cool coincidence there. C++, or C minus minus. Or I can go plus C, also works, by the way, as does minus minus C. Does the same thing. It's just the order. When you evaluate this, it evaluates something else, which is kind of cool. All right. So these, we can call these unary operators. There. Plus, minus, minus, and some other ones. Okay. So there's another unary operator. It's called the spread operator, ... Okay. The spread operator is a unary operator. It works on a single operand. And, for example, if I just say A plus B, there, that is what we call an expression. A plus B. An operator operating on 2 operands, it's an expression. It evaluates to something, doesn't it? Whatever that is. 6, maybe? Sure. Which means I can put a variable const y in front of that, and I can assign it. This is a valid statement. It stands on its own. Or even this. This stands alone. It is a valid expression. I'm not getting any red weird stuff in my VS Code, so it must be valid. Okay, I've got a lot of trust in VS Code, I guess, for something that can't understand classes components. Okay, so we have the spread operator. So if I go const array equals 1, 2, 3, there. And I use my unary spread operator on that array, dot, 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 array. Now, this is unique among unary operators in that it doesn't stand alone. This does, but this doesn't. You can't do that. Look at that. Getting some funky error. This thing does not evaluate to anything meaningful. It is not a valid expression, dot, 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 array. And this is spread operator. So what's happening? This is the spread operator operating on an operand, and it is invalid by definition. It doesn't work. So what's going on here? What is the spread operator actually doing to my array? And why is it invalid? All the other ones, if I go C++, C++, these are all valid. No one's complaining about these things. Works great. But I can't do this. Or I can go minus minus C, be more. There, let's go plus plus, even more similar. There. Or, come on, minus minus C. There. These stand alone. This doesn't. Okay, so what's happening here? Well, as was pointed out correctly, what it's doing is it's spreading or iterating the items into a simple list, what it does. There's a much easier way to think about the spread operator. What it does is this. It takes this array and just strips off those two braces. There. That's all it does. It strips off the outermost braces and you end up with this. And that, if I go const, use x equals, it's not going to like that. It's like, what do you mean? So I can't go const, let's do a let, x equals, and say x equals there. There we go. You can't do this. And have I used x already? Let's take a look. X declare, oh, here it is, of course. Let's take this one. There we go. Okay. So this is invalid and, oh, there. Okay. It's got so confused, this one. Let's put this here. There. Okay. So this is not a valid expression. You can't go x equals dot, 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 or it just doesn't make any sense. You can't do this. So it really is stripping our array. It's stripping off the outermost clothing, if you will, of our array. We have a naked array. Okay, well, JavaScript is a family-friendly language. We can't go having naked arrays all over the place. That'd be bad. So we have to put clothes back on them, like this. There. And now it's valid again. Everyone's happy. Okay. Parents can take their kids to JavaScript shows again. That's what it does. It strips off the braces, but it can't stand on its own. You then have to dress it back up again to make it valid. So dot, dot, dot array really is just dot, dot, dot. Instead, it is 1, 2, 3 again. So it's the same as 1, 2, 3, because that's what dot, dot, dot array is. It's 1, 2, 3. There. And that's why the spread operator allows us to copy an array. Because if I say, we'll make a copy of this array, well, I could say const array2 equals, and I'll just type it in, 1, 2, 3. That works, which is the same as going dot, dot, dot array, because it is, in fact, the very same thing as if I had typed in 1, 2, 3. inside new braces, and it is a new array. This is a unique copy with a different reference, and this is why this works. And we can use this in other ways. For instance, let's say I want to, just take it out. Let's say I want you to copy an array and add 4 to the end. So I can do that. I can say const array 2 equals 1, 2, 3, 4. There. Now I've copied the array and I've added 4, haven't I? Well, that's the same as going ... array, 4. It's the very same thing because this is, by definition, 1, 2, 3. I'm beating this to death, but it's really good to understand what you're doing with spread operator. Okay, you can raise a flag, say, "Okay, Gary, we get it. You can stop now." Right. So this allows us to add things and copy them in one operation, like doing a push and the slice all in one operation. So my app, I combine this in one operation, take this out, and go comma text, and this would work. Make sure it does in fact work. Tom, and we can. That works. In fact, what you'll commonly see is not even the variable. We can just take the whole thing and do it all in one line, and this is the way you'd normally see it. Like that. Copy and add, make a new array, all in one operation, and this does in fact work perfectly. Okay, so this is how this spread operator does its thing. Takes off the outermost arrays and it makes a new one. All right. Now, in answer to the question, is that all it does? Well, the actually answer is that's not all we can use spread operator for. Can anybody think of anything else we can use the spread operator for? Would it be another use? Like, how could this be of any use to anybody? Spreading those things out with commas. Anyone think of how that might do that? What do you think? This is a great example, saying ... array. But what else can we use this for? Maybe even without having the square braces. Is there any situation where this would work? Let's try one. I want to print the items in this array. So console.log 1, 2, 3. I want to print the array. Why don't I simply go ... array? And that will work. I can print out all the items regardless of length because console log expects comma separated values, as does any function. So I can pass the items in an array as individual elements to a function. Yet another use. Now objects, const obj, it works the same way with objects. Equals name, there, say Alice, and email is alice@gmail.com. There. Okay. I can spread Alice as well. So ... obj, which does not stand on its own. I end up with just this. I've got that, which of course is not valid code. What if I put some curly braces around it again? There. Now I do have valid. I can go, let's get rid of that. There. Const new Alice equals there. This is now valid. So I can go ... Alice. Same thing. Now the interesting thing here is, what if I put something else in here and I go age 29? There. What's going to happen here? Well, I'm going to end up with ... Alice, comma, whatever I typed here. age 29 inside an object. So I was able to add something to my object. Works great. What if Alice already had an age? There. 28. There. I want to do this. What would I end up now? Would I end up with this? There. There. And const new again equals there. Do I get this? Well, no, I can't. This is an object. These keys must by definition be unique, right? They have to be unique. Only one can exist. You cannot have two keys the same. So what does JavaScript do? Well, the last one wins. That's what happens. The last one wins. I end up with that. There. So what I have done is I have modified this age, made a copy of Alice, all in one step, and modified the name. Also, name, Bob. So we can modify any item in an object very quickly using this spread operator. So this is a very, very common pattern in React for modifying an object. With an array, it's used to add items, but objects used to modify them. Extremely easy. And it saves us having to make a copy, then set the item. It's a really nice one-step way. You will see this all the time in React. Spread operator to modify a object item. All right. Let's do some more examples of immutable updates, because there are a lot of fun things. Let's go ahead and let's make a little file called immutable outside of source. Come on. There it is. Okay. So we're going to go ahead and put our Alice back there because that was kind of a handy one. There. There. There's our Alice object. And let's just go ahead and console log Alice. We can see what's going on here. I'll call this one Alice. There. And let's make sure Alice works. So node. There's our Alice. Okay. So we know we can make a new one, const Bob, or the other one. We'll do, what's another one of the Scooby Gang? There's Alice, there's Bob, there's Carol. That's right. I'm thinking of the Scooby Gang of names that you always see. Alice, Bob, Carol. Who's D? Dean? I'm trying to think. I think it's Dean. Can't remember. I do know that M is Mallory for malware. I really feel sorry for anyone called Mallory because they really get a bad rap in the computer world. You know, Mallory, listening to the conversation between Bob and Alice, like, come on. You know, I guess they had to pick a name, but poor Mallory. Right. So I'll just say this is going to be Carol. Equals, we're going to make a copy of Alice. Alice, and make it a new object. Great. Okay, and let's console log Allison, Carol again, just to be sure. There we go. What I expected. So now I'm going to, of course, change Carol's name. That's right. Yeah, it is malicious or malware. Exactly right. In the security world, it is called malware for that reason. Malware or malicious actor. Exactly. It was just too tempting, I guess. But I still feel sorry for Mallory's. You know, I'm sure they're very nice people, but they get a bad rap in our world. So, okay. So I'm going to go ahead and make Carol, give her the name Carol. So I can do this all in one step. Name, Carol. And now I have Carol and Alice. Let's put a quickly console log. I'll put a extra line in there so I can see what's going on there. That's useful sometimes, just to put a blank line. I got a blank line between the two. Okay. This is cool. So it's doing exactly what I expect. And I could also just change the name, right? I can go age 28. I'll go 29. There. So far, so good. Email, well, you have the same email. We don't care. So this is fine so far. This is working exactly as I expected. I've made a copy of Alice. Okay. And I've changed the name of the age and I get Carol, and they are two unique arrays. In fact, let's even test this as console log. Alice, Carol. We should get false, shouldn't we? We do. They are different references, just to be absolutely sure. Okay, so let's say we have something else. Why don't we say we now have favorites? And that's an array. Let's say we have coffee and pizza. There. So these are Alice's favorites. And by extension, Carol's favorites, because we made a copy of Alice, and now Carol has those two favorites. And Carol is a copy of Alice, which means it should be safe to work with, right? We should be able to do anything you want to Carol's array or object and not affect Alice. So we can go Carol. Let's say Carol has another favorite. Carol dot favorites dot push. We'll push hot dogs. Hot dogs. There. Carol also likes hot dogs. Okay, so let's take our Alice and Carol. Okay, so there's Alice, and it looks like we've modified Alice, even though we had a copy. Carol is a copy of Alice, but it looks like we still modified Alice. So we mutated state without intending to. And this is what can happen with immutable updates when you have more complex state. This is a problem. I have mutated the state or this object, even though I thought I had a copy. But turns out that favorites, what's that? That's a reference, right? That's probably memory location that, right? Well, I get the same one, the same memory location in Alice's. So they end up with the same array reference. So when I push into Carol's array, I'm in fact pushing to that array there, which is the same as Alice's. So it's a big problem for me. Can't do that. It's a problem. So this is where it becomes more complex. Updating complex state. What can I do? I mean, there's a couple things I could do. I suppose I could do equals dot 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 Alice dot favorites. Favorites, comma, hot dogs. There. See what happens here. Okay, so that's better. Now I've made a copy of Alice's favorites and Carol has it, and they are in fact different arrays. So this is one way. I could have done this all in one line. It gets scary. I could have said comma, favorites, and done that. Yikes. I'm sure it's going to work. Let's take a look. Well, it does. But now it's getting kind of scary, isn't it? what I'd probably do in this case, I would do this. I would say this first. I'd make a variable called favorites. I'd say const favorites equals. And then I'd simply do that there. When I want to create my Carol, I'd say favorites because now it makes the variable the same name. I can use the shortcut and I should end up with my same hot dogs, and it works. So there's no one way to approach this, just they're all a pain. This is one of the pains of React is being sure you don't mutate state. And as you can imagine, as these get more complex, it becomes more complex to update them without changing them. So they can get worse than this. I've seen some scary ones. This is why we avoid, where possible, very complex state. Now, this belongs as an object. So in state, this would be a user state, right? Perhaps user or person state. It belongs together. So we shouldn't really split up Alice and have a state for a name. It wouldn't make any sense. That would be horrible. We should have a user object saved in state and just be careful how we update it. You may even have an array of users in your state. That is also legitimate. They are as a homogeneous array of users. It gets a bit scary, but it does make sense. However, dumping a bunch of non-related things into a single state object, that wouldn't make any sense. I would avoid doing that where possible. Okay. So when you try to build objects and arrays, make sure that what you're adding to state, make sure they belong together logically as a single state item. If not, make another state. There's no harm in that. It makes your life much easier. So let's take a look at some more immutable update patterns. Let's go ahead, and what I want to do now is I want to, if I click on one of my items, I want to delete that item. That's kind of my goal now. Click on Tom, Freddie, or Betty, I guess. There. Add. And Nathan. We got a few of them here. There. Okay, and James. Got a bunch of names here. So I click on a name. I want to delete that item from my array. And by the way, it's putting at the bottom. I don't want to add to the bottom. I want to add to the beginning instead. I think I'm going to change that. So what we can do is simply take that text and guess what? Put it there instead. And now they reverse the order. So now let's take a look. So I got James goes on top and goes on top. There. And Betty. So this you can't do with a push, can you? There is no push to the beginning function in JavaScript. So this is very useful, very common. We just add to the top of the array rather than the end of the array. So I want to remove something from this array. Okay, so I'm going to make a function called delete item. Delete item. There. I'm going to give it the item to delete just for now. It's not the best way, but do this. And I'm going to make myself an on-click handler on each one of these items. Now, when I click on it, I'm going to have an on-click, which means it needs to be right here, right? So this LI has got to have an on-click. So let's go ahead and make this a little bigger. Put it here, maybe. I'll just split it out. It can't hurt. There. There. On-click. There. Equals my delete item. Okay, there we go. I'll put it there. A little better. Okay, so now I'm calling delete item with every item. How about how it's looking? Any crashing yet? Let's take a look. I'm going to be surprised. Oh, no crash yet. Okay, that's a good sign. So now I need to delete my item. Let's console log my item. So log my item just to be sure I'm getting the right item. Okay, there we go. Okay. Oh, wait a second. What is that thing? That looks familiar. Yes, that's the event, wasn't it? So what I've got, my on click here, there it is right there. It's being called by the DOM. I'm getting the event. I don't want that. I want the item. Okay, well, can I do this? Well, I can't because this is going to call it immediately, isn't it? Don't want that. Now, when I call my function or my render, it renders immediately. We don't want that. So I don't want to call this right away. What I want to do is make this a function. So since my DOM calls it with event, but my function needs something different. This is the case where you almost always have to use an inline function. You have to do this way, there. When your function takes something that is not event or is not what this element will call. This might be your component, in which case you can get away with it, but this is a DOM element. I know this particular on click, it's going to give me event. Well, I want to ignore event. I don't care about the event. I want to call it with this item. This item only exists in this loop. It doesn't exist anyplace else. It only, now I could have put the function here, right? I could have put like this, but now I can't reference it anyplace else, right? So, and this is also very inefficient. I could have done this, but this is very inefficient. There. It does work now, but that would not be great. So in order for my function to work, I need to have this inline function as my on-click. It doesn't happen often. You get used to them after a while. Pretty soon you start doing this all the time. But this is a case where you can't use a named function directly. You have to do it this way. Okay. Let's take a look now. What happens when I click on something? That, if I click on one, so Betty and Freddie go Tom. I'm going to add a feature. I'm going to add a feature that clears out my array when I add, because that's annoying me. So let me do this. I'm going to go here and add item. Set text to empty string. There. I feel better about this. Now if I add James, it's going to, there. I like that. Nice little feature. Okay. Now I want to delete one. So if I click on Freddie, it should now hopefully, there we go. Got the right item. Now I can look at deleting this item. Okay. So how do we delete something or remove something from an array? Now this is a very, very classic problem. I'm going to call it remove. It's sounds more nice than delete. Remove item. Okay. This is a classic pattern. How to remove an item from an array. Might even be an interview question. They might ask you, hey, quickly write some code to remove something from an array. Okay, well, there's a lot of ways we can do it. Okay, depending on the complexity of the array, you might simply just get the index and like remove it. That's easy, but immutably. So that doesn't work. You can't just get the index of the item and then remove that item because you're mutating the array. So I want to immutably remove the item from this. Now, what can we do? Well, it turns out there is a function in JavaScript that is specifically made just for this. Just like map is your best friend for, well, mapping an array, there is a function that we use all the time in React. Who wants to guess what that is? Let's take a look. I'm going to ask Google how to remove item from on array JavaScript. Sure. Okay. Pop Well, we can use pop, right? But we don't want to do what that does. That modifies the array. So nope, not doing that. Okay, there's also slice. Okay, that will remove things simply, but we want to remove one thing. There's a couple other ways. Okay, so we can use splice, also works, but turns out there is one function to rule them all when it comes to changing an array or removing things from an array. That is called list.filter. That's the one function. Okay. That's exactly what it does. Const new list equals list.filter. And it takes for every item there. It will, I'll put them for now. Anything you return is going to end up in the new array. If you don't, it's gone. So this is probably one of the most flexible ways to do anything with an array. Filter it. So when you see filter, that's what it's for. It's to remove something from an array. It will also, I think, return the removed things, or it'll return the new array that you've made. So it is a copy of the original, right? So I'm going to return, well, I'll just say, I want to return anything that's not the item, right? Return anything that's not the item. So when you return true or false, let's say I return true. There. It's going to just nothing. It'll give me back the same array as before. If I return false, it's going to add nothing to the array. So true or false, if you turn true, it adds that item, false doesn't. So false, if I click on anything, it's going to take them all out, right? I haven't done anything yet, but okay. So in this case, I want to return is, let's call this I, because it got item used, right? Return I, which is my item here inside the loop, is not equal to my item. There. I'm going to call this text. There. By the way, rename variables, you would go right click, rename symbol, right? I'll say text here. Oh, that's kind of interfering too. Oh, doesn't matter. And now I'll call this item. I guess I really should have chosen better name, shouldn't I, than text as my text. Okay, so it'll filter out and only return those items which don't equal to the parameter I got. Okay. All right. And now I'll just console log my new list. Let's take a quick look. Okay. Let's go ahead and go here. And now if I click on one of them, I should end up with an array without Freddy. Ah, great. An array without Tom. Hey, great. Okay, so it is in fact working. Now I can go ahead and just save my state. So set my, oops, there we go. Set list to my new list. Just like that. There. So now I can click on Tom. He's gone. Yes, okay. Sorry, I'm being too pleased about that. I actually don't mind Tom Cruise. What's your favorite Tom Cruise movie? Quickly, take a vote. I do like Edge of Tomorrow. That was a cool show. That was a cool show. Oblivion was kind of cool too, you know. Mission Impossible. Yeah, there's
The Last
action.
Samurai. I think I remember well.
Yeah, that was kind of cool. Yeah, that goes back a while. Yeah, yeah. Risky Business. Come on. When he was like, what, 12? Can't remember. Yeah, so he's had some good shows. But, you know, why does everyone hate him? I don't know why. So, well, anyway, okay. I guess he's just a good target. So it's working great. Look at this. I can remove stuff. Fantastic. Of course, there's a better way to do this, isn't there? I would simply say set list to this thing, and I wouldn't put a return. I'd simply take out the curly braces and instead do this. This is the way you'll see it, by the way, done this way, and probably done like this. it doesn't take away from the readability because this is a common pattern. A React developer would look at that and go, yeah, I know, I see what you're doing. It's a filter, no problem. This is such a common pattern. Very, very, it's like a for loop. Nobody confuses a for loop. So you can see what it's doing. It's simply removing an item. Okay. This is what you'd normally see. Let's give it a try. So put Tom back in. We'll add him twice because we feel sorry for deleting him the first time. Okay. And James and Nathan. There we go. Okay. Great. Does it still work? Let's take a look. We'll take out Betty, although everyone loves Betty. Betty White, right? Okay. Old golden age actress. Look at this. Working fantastic. Great. And looks nice too. Okay. Let's try and click on Tom. Let's remove that Tom. Add another Tom just for fun. There. Let's click on this Tom. Whoa, all the Toms are gone. I mean, yeah, but not what I expected, right? What's going on? Well, this is just a logic or a design error in my function because I took the text. So if the item text equals the text, it deleted all of them with the item. I probably should use something else, maybe with an I or a UID, and maybe had an array of objects that contain the ID. Returning the I might not be a good idea because that's, as I said before, this can be kind of scary to depend on that I inside a loop. I'd really feel not good about doing that. In fact, it could be dangerous. So really my array should be an array of objects, shouldn't it? Probably name and ID like this, right? And then there should be objects like that. Ideally, this would be the way they'd look. An array of objects there and a bunch of those like that. Then I could use the ID, which is unique for each item. But I didn't do that because I don't do that. It's kind of a lot of work right now. So, but it does demonstrate that it works. Okay, there we go. But yes, if I have two Toms, it will delete all the Toms. There. So one James and two Toms. Okay, so that's our talk today on state, our second part. Really takeaways from today, it is understand how React compares state. It just doesn't equal, which means you got to be really careful not to modify the original and make sure you have a new one. Otherwise, nothing's going to happen. And your component is not going to render because you've modified the original rather than making a copy. And watch out for this complex state. That will get you. And there's lots of examples of that. Yeah, question.
Gary, question. Oh, yeah. So in the example of a complex state or objects, when you're using filter, I guess the spread operator would be a good example to compare the items you want to remove.
Well, in this case, I'm only saying text. I don't really know which one. I'm just saying because my remove item function only knows it's got Tom. That's all it knows. I would have to pass it a different parameter here. I could give it I, okay? And that might be better, but then I got to find out which I, and it is really dangerous to use an index inside a map. I feel kind of dangerous doing that, honestly.
Yeah, but I'm talking more generally. If we're gonna use filter with not just a value, a specific value, but more with a complex object.
Oh, absolutely. In our Immutable, we could have, or in this, we could have probably, say, want to remove something from Carol's or from Alice's favorites. We could have gone equals Alice.favorites.filter and remove an item as well. So spread is used to modify objects or add to arrays, but filter is used to remove from arrays. And we can't do filter on an object because it's not an array, I'm afraid. Okay.
Yeah, so to compare if we want to remove an item versus an item, we would compare the spread of an object versus the spread of another object. Would that work?
Well, the spread of one object, that they're always different then. Since the spread always gives you a new,
Okay.
yeah, we generally use filter a little simpler than that. We really just do a simple equal. We take the thing. Now, if this was an array of objects, for example, item dot ID, and I got ID as a parameter, and this is something, by the way, you do get, equals my ID there. This is a more realistic thing. You give it the ID somehow here, and it's an array of objects here with name and ID inside them. It is uncommon. You'd have just an array of names like that. It'd probably come from a database or some API, and there's almost always a unique ID in every API out there. It's almost unheard of. You would not get an ID back. All right. Okay, everyone. That is our talk for today. More work on our Photo Labs, which has lots of interesting stuff in it starting today. All right, everyone. I'll talk to you guys again soon. Hey, guys. Have a great
Thank you. Have a good
rest of your day.
Thanks,
Bye,
Gary.
guys.
Thanks, Gary.
Bye.